Pre-calculus chapter 3 sections 1 and 2, we're going to work on some applications of exponential and logarithmic functions. Some of you have mentioned that you remember compound interest or you've seen compound interest, so some of you really didn't know what we were talking about to start it. Let's talk about what we're doing here. First of all, these two formulas. We have two different compound interest formulas. One is if you are compounding a certain number of times per year. The other one is continuous, where it rolls the interest. So A is your final amount of the formula. P is the principal amount. You know what? My brain is not telling me whether it's AL. No, AL is the person. Sorry. Oh, no, AL. It is AL. Principal amount, or the amount you start with. R is interest rate, and it needs to be in decimal form. N is the number of times it's compounded. You only have that in the top formula. T is your time. And we're talking about time in years, sorry. So if it says it's compounded quarterly or monthly or daily or weekly, anything like that, you use the top formula. If it's compounded continuously, you use the bottom formula. Looking at example 8, you invest $12,000, that's P, at an annual rate of 3%. I'm going to put 0.03 for R. Find the balance after 5 years when the interest is compounded quarterly, monthly, and continuously. Quarterly, N would be 4 for 4 times a year. Monthly, 12 times a year. Continuously is the PERT formula. Okay, that's what we call it. It's obviously not exactly PERT. Let's go with A first. P equals, Miss Fenwick, you're losing your mind. A equals 12,000 times 1 plus R is 0.03 over N, 4 to the NT power. And when we do that, plug it all in, remember that this is money, we end up with approximately $13,934.21. B, let's change colors so we can tell which one we're on. Same formula, 12,000, 1 plus 0.03 over 12 for monthly, 12 times 5, and this one gives me approximately $13,939.40. $13,000, 939.40. So it's really not that much difference. Obviously $5.20, or almost 20 cents. But that's not much considering it's the same 5-year period. A little over $1 a year. So the next one is A equals the principal, 12,000, times E to the R, 0.03, T, 5 power. And that one gives me approximately $13,942.01. So obviously continuous compounding is usually going to give you a higher return, but you can test it out with daily, you can test it out with bi-weekly, things like that, just to kind of see what's going on. Now, the next kind of problem that we're going to use, usually the information or the formula is given to you. So in this one, we're talking about the nuclear reactor accident in Chernobyl, which I recommend that if you don't know anything about it, you go look it up. Obviously, this only tells you a little bit, but the explosion spread highly toxic radioactive chemicals such as plutonium over hundreds of square miles. The city was evacuated and the surrounding area. The city is still uninhabited at the time of this. I assume it still is because I did the math the other day. So if we consider this formula, P equals 10 times 1/2 to the T over 24,100 power, which represents the amount of plutonium P that remains from an initial amount of 10 pounds after t years. It says to sketch the graph of this function over the interval from t equals 0 to t equals 100,000. Here's what you need to remember. We forget about this a lot. T equals 0 represents 1986. So t is the number of years since 1986. How much of the 10 pounds remained in the year 2017? How much of the 10 pounds will remain after 100,000 years? So if we sketch this, notice that our that our base is a fraction, which means it's going to come in from the left. It's going to come in from 10, which was our initial amount, and do this, which means it's getting smaller all the time, correct? Well, at 0, I guess technically I need to erase this right here because it can't go back there. We're not to have negative time that we're talking about. So we start at 10. So at 0, we had 10. At 100,000, we're going to talk about in just a second how much is left at 100,000. Using our formula, P equals 10 times 1/2 to the T over 24,100 power. They want to know 2017. So to find T, you do 2017 minus 1986, which is 31 years. So after 31 years, if I plug this into my calculator, because we ain't trying to do that by hand, you have approximately 9.991 pounds. But wait a minute, how many pounds did you start with? Oh, that's right, 10. So it didn't go much further down in 31 years, did it? Now, how about in 100,000 years? 10 times 1/2 to the 100,000 over 24,100 power is approximately 0.564 of a pound. A little over half a pound, guys. Okay, just for the sake of doing it, let's say now, 2021. In 2021 minus 1986, yes, I'm using a calculator because I don't want to tell you wrong. We're at 35 years, which I could have told you from here. So if we plug that in, 10 times 1/2 raised to the 35 over 24,100 power is approximately 9.899 or 9.990. Golly. You guys, that hadn't gone down much from that initial 10 pounds, and I don't want to be hanging out where all the radioactive stuff is. Hopefully you're the same. All right, we will come back with the log applications in the next video.